wonderful evening, which is going to be a knowledge enrichment session. Today we have an artist architect who is proven his capacities at the various level of field of architecture. For giving an introduction about him, let me first officially welcome you all to this first webinar initiative of PMI Kerala Forum. So I welcome you all formally on behalf of PMI Board of Directors and as well as all members. And I will give an introduction about the speaker. Regarding the speaker, before talking about the speaker, I will tell you the relevance of the subject at the present in this pandemic situation of the COVID outbreak. Things are changing, and the field in the construction field, there is a revolution going to happen in architecture, and which is going to be a trend for the future. So here, an expert in that area, that is sustainable architecture, we have. He is rendering a talk on a subject called more with less. That's a version of sustainability in architecture. With my, I am very much delighted to introduce you to the gathering. Let me introduce him. Architect George Chittoor is of legendary architect Laurie Baker, and who has closely guarded his sensitivity towards the design of elegant, ecologically sustainable, and intensely individual architecture. He worked each project passionately with the zeal to perfection and satisfaction, paving the way to an architectural experience that seamlessly fuses the realities. The diversity of the commissions handled by his firm, GJC Designs, ranging from commercial, institutional, hospitality to has given a clear perspective into the demand of clarity of design, compatible spatial orders, alternative technology, and eco-responsible buildings. Architect George Chittoor has been awarded the Best Residence Award by Malayalam Manorama Parkudam in 2007 for the Courtyard House at Mannar. The day at the Info Park Kochi was nominated for the Best Institutional Project by NDTV in the year 2014. He has served as the Honorary Secretary to the Indian Institute of Architects during 2014. With pleasure, I welcome Architect George Chittoor to this wonderful this session. Sir, please, it's over to you. You can start. Thank you, sir.
Yeah, thank you, Unni, for the introduction, and I congratulate PMI for initiating this project management in the engineering session, and I'm really honored to be called in for the first session. So I thank you, PMI. So I'll just go to sharing the content. Okay. Once again, all thank you. So this webinar is a new thing. Seminars online is a new thing, but we are fast catching up with this new trend of coming together. You know, with this COVID in time, or else we would have actually come together in a conference hall. More people, more coming togetherness, and that physical coming togetherness. We miss it, but still, this is a platform where we can come together. So I'm just wondering during this time, if this becomes a new norm, just imagine after 2 generations, maybe your grandchildren come to you and say, Apacha, I cannot imagine that 100 people or so could come together in a conference hall. Just imagine the kind of resources that you're wasting upon. Just imagine that for 100 people gathering, say 50 cars running around the city for parking spots, if it is not available, people coming at random times. So the kind of electricity and kind of air conditioning that all is required, the energy that is required to organize such a meeting. So with this online webinar, it is a new platform where we are conserving resources, and this objective of knowledge sharing is also happening. So it is a new thing. It is a new norm now. So it shows about our ability to change, consciously or subconsciously. You and me, both of us are evolving. We are adapting to change. So this session today is going to be about this aspect of change and sustainability. So good evening all to the discussion, where I'm going to take you through doing more with less, or accomplishing more with less, to being more with less. I welcome you all. So this is one of the principles which we premise our practice on. Architecture is both art and science. So for us to conceive architecture, we cannot think of it as science alone. We need to have that human factor. We need to have that empathy part to understand what the user is or what the audience is about. So that is where art comes into picture. And to get this art done, we need the help of science. And over a period of time, we are not able to distinguish between what is art and what is science. So both these are together for us. It is like once you start driving and then somebody asks you about which one do you press first? Do you press the clutch first or the accelerator while starting? So it all comes as a flow to you in between. So all these principles comes to you in our practice. So so we see our practice as both art and science. One of the three major principles or pillars that form our practice is, one, as I said, is the art-bound visual engagement. Second, we give an importance to the utilitarian part. And the third is sustainability. So it gives us the ability to understand the entire context in a whole when we see architecture from this premise. These are the two words, green and sustainability are the two words that are often used interchangeably. So I thought I'll just define both these words first. So green refers to the activities that provide a more efficient use of resource and minimize the harmful impact on the environment, while sustainability has this time factor to it. Sustainability refers to the activities that allow a specific problem to be solved without having an implication on in the future. So it is like you're doing something with future in mind. So it is nicknamed like a grandchildren theory. Sustainability is about a grandchildren theory. You're reserving Earth's resources for the future. You're reserving the Earth's resources for your grandchildren. So it takes you off the consumerism part. That is the difference between green and sustainable. Green is subject oriented, while sustainable is more time oriented. Next, I've devised a kind of 4 chapters for this entire session. So the first chapter is about change. Remember when I said about this coming togetherness on a virtual platform? Before, it was not thought of. We used to have client presentations in Zoom and Skype all those softwares, but it was pretty difficult to convince the client to come on a Skype platform and then do a presentation. So there we had earlier itself we had tried, and we have all these options of how can we work remotely, like our staff working at different places. Even before the COVID times itself, we had this thought about instead of coming together, is it possible for a person from Pathanamthitta or Kottayam to work in the office to brainstorm? So all these things were earlier thought of, but there was no necessity that for us to implement it. So we had tried it out earlier, but now it is much more easier when we speak about Zoom. Whenever a client comes, we said which platform are you comfortable? Is it Zoom, WebEx, or Skype? So we are more friendly to all these kind of new changes. So that is a welcome thing which we have adapted. So once we start noticing this change factor, we'll just focus on this virtual platform itself so that we can understand the character of change. So how did it start? We first identified the constraint. We had this necessity that we need to come together. We felt this void when we were sitting in isolation. There needed to be some kind of a knowledge upgradation. There need to be some kind of a socializing. So we are used to, as human beings, we are used to this. So how do we come about it? That is when we identified this constraint. Then we weighed the need of change. We understood that we need to have a change in it. So that is how we necessitated or desired for a change. Then we sought to opportunities of continuity where we wanted to socialize. So what is the other platform that we could come together? So this is just to show you an example of it is possible to adapt to change. And when we see a change, we realize as human beings that we need to come together. We need to evolve to accept this change. The same thing goes in the building construction industry as well. The key takeaway from this first chapter is once you identify, you're able to change. But what if you're not able to identify? What if you're not able to foresee the constraint? We've now all of us are accustomed to using M-sand in our practice. In 1980s, when the first company that manufactured sand saw that there is going to be a stoppage of the river sand at some point of time, they started manufacturing sand. Popson was the first company to start off this activity of manufacturing sand. So when it was identified, one of the entrepreneurs they thought we'll initiate this change, and that was in 1986 when this whole endeavor. I remember in my youthful days, it was considered as a foolish venture. It was a foolish venture. Would river sand ever stop? Would this material ever run out of uh, stock? Well, it did. 20 years after it is nearly over. In 2005, the ISRO and BSSC, they changed their spec to include M-sand. I think it is in 2005 or 2006, which means roughly in 20 years' time. In 20 years' time, there was a change, and it was formalized that river sand is no more existent. Now, whatever river sand you have received after that was more or less adulterated, and now whatever was there in the dams, the cleaning of rivers, whatever river sand you received from that contains a small debris which is also not so good for the plastering and all the other purposes. It manifests at some point of time, the debris afterwards. So this is this premise where we need to be open to change. We need to be open to innovation. So that is the first mindset that we need to adopt while we speak about sustainable architecture. The next chapter, I'll be taking you through the less and mores of building materials, construction techniques, etc., and my own uh, my own experiences while utilizing all these things. Now, greenhouse gas effect is the sun emits radiation, the earth absorbs this radiation, and the earth re-emits this radiation into the air. And there are certain gases that absorb this radiation, the heat energy, and then give it back to the earth again. That is how the temperature is increased, and it is not, it is covering the whole earth. That effect is called greenhouse effect. And the greenhouse gases that contribute to this is carbon dioxide, methane, nitrogen oxide, and fluorocarbons. Of this, carbon dioxide is what we are concerned about. So building industry, we generate more carbon dioxide during the process of manufacturing of the building materials. So in that, we need to know that 76% is carbon dioxide, and researchers show that 8 major sectors contribute to the production of carbon dioxide. Of that, it is power station, industry processing, transportation fuels, agriculture byproducts, fossil fuels, commercial and other sectors, land use and biomass burning, waste disposal and treatment. Of this, the second one, the industrial processing is what the building industry is more is using. Of this, 80% is being contributed by the building industry of industry process. So these are the certain terms that are associated with sustainability. When you speak about sustainability, these terms often surface up. So it means your aim is to have less embodied carbon. So what is embodied carbon? Embodied carbon is a carbon footprint of a material during the production. During the production, how much of carbon it has emitted. That is the measurement that we take while saying as embodied carbon. The other term is embodied energy. Embodied energy is a more easier term. So it is a sum of energy that is required to produce all the goods and services. So this is a kind of chart where you compute the embodied energy in any material. First, you take the raw material, how the raw material is manufactured, how even the transportation is taken into place, where the raw material is mined, how it is brought to the industry, and what and all processes are there to make it product ready for the industry. So that is how the energy is computed. In case of cement, this is a trial chart where the limestone is extracted. The embodied energy that is needed for the extraction, for the transportation to the place where it is going to be mixed, the clinker production, the grinding, the packaging and storage, and ready for dispatch. This entire process is how embodied energy is calculated. So these are some of the embodied energy standards that are there in the Indian engineering manual. So they've practically identified most of the materials, and even this is a general term. It is not a conclusive or a standard material, because from place to place the embodied energy production for brick in Bangalore or Karnataka is not the same as in Kerala. In Kerala, so each and every place and each and every context, this embodied energy calculation is changing. But we can use this for a general purpose of calculating a construction technique. So here you see brick in the second portion where it is 3.6 to 6.3. Even there you can see the different kinds of brick production. Then you have the ferrocement, and this is an exhaustive list. It is long. I've just taken 2 pages of the book. So that was energy in the production of building materials. Now you need to think about less waste. So every building has a life cycle assessment. Every building in its entirety takes up resources in the production to the end, while after a certain life period it needs to be demolished. So this life cycle assessment is a environmental impact computation, is a measure of environmental impact that a building takes up. So there is an energy impact, there is an environmental impact during the production stage, during the construction stage, during the use stage, during the end of life stage. In the production stage, there is a material supply, transport, and manufacturing. So buildings consume these resources of land, soil, trees, metals, plastic, water, electricity. So land in the form of farms, forest, fertile land, soil for the earth, clay, limestone, silica. During cement production and all, we use silica, sand, trees for our interiors, wood for the joinery details, metals, steel and iron, aluminum, copper are all being used by metals, by buildings, plastics, water during construction for the landscape, during the running of the project, electricity. So all these are resources that are consumed by building. Now buildings also generate waste. So site waste is something that is during the site clearance, initiating of the project where the trees are cut, the vegetation, the excavated soil. Then during the course of construction, there is a waste generated, which is the metal boxes, broken bricks, shuttering oils, etc. Sewage during the operation of the building, the sewage that is being produced. Organic waste during the life cycle of a project, vegetable, fruits, kitchen waste. Now there are inorganic waste which can be recyclable and non-recyclable. Recyclable contains paper, glass, metals. Non-recyclable, demolition of debris, plastics, synthetic fibers, etc. Then during the production period, e-waste, CDs, electronics, hardware, chemical waste, adhesives, paints, etc. So these are the kind of waste that is generated during the life cycle of a project. So next we'll go into, I'm just running through, this is the science part of the subject. So next I'll go through the components, general components in a building. So the foundation, how can you be sustainable in foundation? Foundation is where we don't speak too much about sustainability because we need to be sure that our building is safe. So there we don't generally compromise or experiment too much in there, but we speak about sustainability when I have to decide between low-rise and high-rise buildings. When somebody is deciding to construct and both the options are workable for them, then I generally advise I go in for the low-rise high-density project. Why? Because it takes a less amount of steel and concrete to build up the foundations than a high-rise building. The same amount of square feet can be achieved if it can be achieved with low-rise high-density. So we generally advise for a low-rise building because it consumes less of materials. So that is how we generally be sustainable in the foundation part. And I've seen lorry maker try out with bamboo and all, but I'm not courageous or adventurous enough to try out those techniques because most of his knowledge has worked out from empirical methods. Those are not standard recommendable theory. They do not have a standard recommendable theory at that point of time. But he has worked out, and now there is a theory part of it. Now there is an authentication. Now Indian standards has approved the filler slab. Earlier it was not the case. Filler slab and all was not recommended or advised in the Indian standards. So we weren't able to advise that to the general clients or institution projects. So, but he is a person who has tried out and has been adventurous. He's as structural engineers, maybe some of you can relate or identify with when you know the factor of safety computation in a project. So he's tested all those factor of safety. He has known it is. He knows when a product is going to fail. So he's learned it from his experience. So he's started his known architectural practice in Kerala at a very late point of time. That is about, he started at, I think in 55, 60 years of age. And he lived on till 95 or so. So within the 60, he had this vast experience of trying out each and every building material. And if you see his projects in Gujarat, I've been told that he's even tried out a full glass building there. So he is a person who has experimented and tried out all the technologies and with the locally available. That was one of the major principles that he used to stay along with. So that is regarding foundation. When it comes to walls, we've got a lot of options coming up. There is this brick. Then brick can be sun-dried. Earlier, in the beginning of my career, we've had projects where clients used to make bricks in their site itself. There was one project like that. But now we don't find any kind of context where people make brick from the site and then use it for the project. Now it is kind of outdated, and we do not have the kind of knowledge expertise. Example for me as a consultant, I only know that this can be done in theory, but there is a lot of difference between theory and practice. You know that when the object is going to, uh, when is it going to fail? What are the failure conditions? What are the required parameters for a building material to be approved? So those are the time-tested knowledge of earlier generations. Now we are running short on those kind of technology part where this can be implemented. So this is a brick, and brick there was the English bond, and Laurie Baker introduced as rat trap bond. It is not, he was not the person who invented it, but it was in general use in England, and this is found to be thermally good and using less number of bricks. The mortar joint compared to the normal English bond was less. So thereby you're saving cost from both these factors. Then we have the solid concrete block. There is this hollow concrete block, the aerated concrete block, the stabilized mud block, the Poratham bricks, Wienerberger bricks. So all these building materials for the walling systems, there wasn't an acceptability towards most of these materials. Brick was the known material for a traditional Malayali. I remember I think it was in 2010 that all these materials started becoming more and more common. We had a difficulty during those periods in convincing the client to use this and making it more economical. Now it is certainly the most economical material, but during the initial stages, and I mean in the 2010s, it wasn't easy convincing a client to use a concrete block. At that point of time, this brick was not readily available. It was getting costlier and costlier, but it was available. Even now, it is available at a higher cost. But what is not sustainable about brick is, in the production of brick, we are using the topsoil of an agriculture field. It needs to have that soil with a kind of what we call pashavashapa, a kind of adhesive, sticky nature to it. Only then that you can produce this good quality brick that is resistant to moss. So right now we are lacking. We do not have this good quality earth to produce a good quality brick. So right now, if you say you're doing a brick building and calling it sustainable, I'm not really sure about how eco-friendly it is going to be. But overall, maybe if you leave it unplastered, it might be as a life cycle product, it might consume less embodied energy, but still, to me, it is consuming more energy. So better than that, even though cement produces more carbon dioxide, I would say solid block, hollow block, aerated building block and stabilized mud is not load bearing. So that is why we'll have to do a column frame structure to incorporate this material. But most of the apartments are now incorporating these materials. And I really like this AAC blocks because it is very lightweight and it can be constructed very fast. I mean, if you have a large area per floor, I think the at least four layers of aerated block can be built up in a day for a wide area compared to brick or any other material. So these are places where project management plays a heavy role. So in project management, you identify what is consuming more resources, what is consuming more resources in terms of material usage and in terms of time usage. So what the easiest parameter to assess all these management technique is to say whether it is costly or not, is to convert it into rupees, and you can see that it is, when it is coming out more economical, it means it is consuming more energy, less of energy. Um, it is not a conclusive theory, but it is a general theory which I always use. Because right now, concrete may be cheap, but later on, looking from the material resource point of view, later on it will get uh, diminished. So we need to take care in the usage of material so that we are using it for the later purpose. So from that point, we need to take care. This is Porotham bricks. It is also widely used. We started using this. The good thing about this patented technology is it was started by a German Weinberger company, and there are many companies that are coming up with similar materials from Bangalore and all. There are many companies that are producing these Porotham bricks, but the technology with Weinberger is this fins in between are so thin, so it seems they've got some kind of a technology that produces thin uh, clay layers in between. So this is also very thermal proof. This is another material which is being recognized widely recently. These are clay jalis. Nowadays, people in our design factors, we've come up with kind of screening the entire building with this material and using an economical or a glass to cover the entire thing, and using curtains at night. So it kind of creates a new architecture. So this is one of the widely used recent materials now. The possibilities are increasing. So all these are creative ways of being economical and being sustainable. This is a bamboo wall. So these are all techniques that can be utilized. So is there one technology that can answer all the questions on sustainability? Is there any one material or any one technique? I don't think so. It is in the wise use, mix and match using of all these techniques that we can conserve and create a good architecture. So it is dependent on our wisdom on the utility part. So when it comes to roof systems, the traditional concrete, then we have this filler slabs with clay pots, and there are mangrove tiles also being used. So these are now common technologies, but the usage is all, we need skilled labor while doing all these technologies. When it comes to normal concrete, it can be easily done, and if there is any flaw, it can be easily rectified. But when it comes to these kind of filler slabs and the alternate technologies and unconventional methodology, the one constraint is it cannot be rectified, or the labor part is the usage of manpower is too high in all these unconventional methodology, and thereby you're a lot of cost and time there. So in terms of material resources, it is less consuming, but when it comes to labor part, it is more consuming. That is why it is not popular. And this is another variant which is being common nowadays. Instead of concreting, you're doing the press work and then laying it with mangrove tiles. And on the underside, using either PVC or there are many materials like the cement fiber board or natural wood to have that elitist feeling. So all these construction, and this is in terms of eco-friendliness, this is much more eco-friendly. It is a bit costlier than concrete, the whole package. And if you use cement fiber boards or PVC materials, it is even then it is a slightly more higher than concrete. In terms of material resources, it's saving a lot. And the whole package of building a project, this would mean less of weight on the foundations, and thereby you'll be saving the foundation cost also. So as a package, this would work out economically. So in the line of when you speak about sustainability is the energy component that being used by a building. So there we speak about human comfort. So when it comes to human comfort, there are two ways. Either it can be a passive one or an active one. Passive in the sense it can be a natural ventilation or naturally lit, or it can be artificially lit or artificially ventilated. So if it is artificially lit and artificially ventilated, it would be using energy. So this is where again your application of wisdom on how much of the project should be naturally ventilated and how much it should be dependent on energy. So this is where sustainability, the questions and parameters of sustainability come into picture. So there your target is going to be how much of renewable energy are you going to use? This is energy pyramid diagram. And how much of energy efficient equipments are you going to use? And then how much of energy are you going to conserve in the project? By energy conservation, there are building automation that is again becoming more and more popular these days. Even we've adopted an energy automation in most of our recent projects, and it helps a lot. It helps us to identify whenever the water meter is running and we know that there is a water leakage somewhere. When the energy consumption is more than normal, we see that there is something wrong in the wiring, and then we are able to identify there's something wrong in some appliance, and we are able to identify. So these kind of building automation, I would seriously recommend if you're a hardcore sustainable person. And it is becoming very economical also. I mean, we've got projects where the client is for the landscaping purpose, the client is watering the landscape from Dubai, and he just needs to use an app and say water from say 9 to 10, a drip irrigation kind of system. So those kind of technologies help the project to stay lively. So whenever he comes to his home, it is always green. He's got a green landscape. So this kind of energy efficiency can be implemented. So the whole agenda is to reduce energy as much as possible. Then we have this net zero energy building. Net zero energy building is a building that is completely off grid or not dependent on the energy resources that is being given by the government. So there are many terminologies like zero energy, net zero, or neutral zero. Basically, it all means being off grid. A completely off grid would mean that even the waste is being managed, is not given to the state or the municipal drainage or anything. It is being managed within the project itself. So nowadays, most of the owners are also, most of the clients are being aware about these kind of terminals, and they come to us saying that let's try out this off-grid project. Let's see how much it is going to cost, and let's see if it is workable. So there are many rating systems in the country, which tells us, which informs us of what is less and what is more. So three such agencies in India is the Adarsh, IGBC, and B. So IGBC was the first one that came about. It was done in it was initiated by the Confederation of Indian Industries. Later came Adarsh, and B is the recent one. Adarsh stands for the Association of Development and Research in Sustainable Habitats. IGBC, the Indian Green Building Council. B stands for the Bureau of Energy Efficiency. So these are the three agencies that give kind of rating system. The rating system given by others is called GRIHA, Green Rating Integrated Habitat Assessment, and all these agencies are giving kind of certification for professionals. They're always inviting people to get certifications, and there is an immense opportunity in that. IGBC is known for LEED certification. They were the first ones to start off. Then B is responsible for preparing this code called as Energy Conservation Building Code. Now this building code is mandatory by the state municipal KMBR, Kerala Municipality Building Codes. So it necessitates the evaluation by a certified professional for every building, every large scale building. So these are the various rating methods that are available in India. All of them are more or less the same. ECBC is a code. GRIHA and LEED are generally the same. GRIHA is a bit more strict, I would say, but then it is always better to adopt the GRIHA system because it is more Indianized version. IGBC was started in 2001. GRIHA was started in 2005, and these are the points that compare both. There is a system of 100 points that each of the rating system needs to have. If you see, GRIHA is a little bit more strict on each parameter. And from the project management point of view, GRIHA is the rating system that gives mark for the project management of the project also. So from that point of view, also GRIHA is better. I would recommend to implement GRIHA for the wider purpose. These are some of the comparison statements in terms of indoor environmental quality. Both GRIHA and IGBC have got all the parameters. If you see over here, all the parameters they've considered: health and well-being, recycle, recharge, and reuse of water. If you can see this slide, GRIHA takes care of most of the parameters: wastewater treatment, water recycle and reuse, whereas LEED does not give a valuation for that. So even if it is to be, even if the building is to be rated or not, I would say having a kind of checklist in all your projects for a GRIHA rating can make a building more sustainable. The process of getting it rated might be a bit tough, but even without the rating certification, you can have all your projects done in such a manner. So what would be the key takeaway in this second chapter is the wise usage of all the resources and techniques. This is where it's mostly science. It is mostly, why is it called science? Because it is more of quantities. There is a lot of quantification of activities and quantification of materials and quantification of the consequences. There's a weighing of each and every decision. Each and every decision has a weightage to it. So this is where project management would really play a role in deciding which is good and which is bad. So next is on the local or the global. So this is more of aesthetics and more of visual imagery when it comes to whether we should be local or global. And this has been from time immemorial that man's aspiration for a progress or a progressive image for each and every person. So vernacular, the original architecture would have, from if you see the primitive architecture, it is always a rectangular box and a sloping roof on top of it throughout the world, and that typology has not changed or anywhere. It can be either cloth or it can be mud, or for the roofing system, it can be either a thatch or a stone or ice blocks in igloo or anything. But it is always that a box and a roof, a box and a sloping roof above. So that has always been the typology, generic typology. So this is a roof in Rajasthan. I mean, a vernacular architecture in Rajasthan. Again in Rajasthan, you can see how slowly the color is getting on added. So slowly art is getting onto it. This is in Tamil Nadu. This is from Mexico. If the children were not there, we could have assumed it to be some project in Wayanad or where the most of the earlier architecture is still existing. This is one from one of the documentation of most of the houses. So you can see on the left side of the panel that most of the buildings are sloping roof, and how during a period it was being converted with the same visual imagery, the building materials were getting changed. But even then, the same typology was there. This is again in Brazil. Then this is in Africa. So everywhere, the same typology of using either a brick, mud, and a roof, sloping roof on top of it, but was the starting point of local architecture. Then, as man progressed, man started to seek out other imageries of being distinguished, or we had an aspiration for being different from the other people, or from the other parts of the society. This is again the next generation from the primitive architecture, the next generation of architecture that took along in traditional architecture. So most of you are aware about these imageries for old buildings. This used to be the vernacular architecture that Kerala inherited, and we had this wealthy, the rich and the elite using extensively wood and other materials. Now, why is this a symbol of the rich and elite? Why would we say that it was rich that adopted this kind of architecture and not this? Because as you can see, this is being done by either a brick or a laterite, and then it was plastered, and there is minimal usage of wood, while this has more usage of it, which means it is more labor dependent. The materials used to be local, while the richness was in the craftsmanship. We used to value craftsmanship much more. Well, as you see now more than craftsmanship, we are depending on imported material. That is where our imported imageries. So there is a shift from being local to being global. This is about an architect called Frank Lloyd Wright. So much before these terms of sustainability and eco-friendliness came into being, this was one person that that coined the word called organic architecture. Now, why was it called organic architecture? So in his theory, whatever materials that needs to be built has to come from the site. If you see his projects, this is his own house called as the Taliesin house. So he's used the local uh, blocks of stone as the walling system. So this was during the mid of his career that he coined this kind of a theory and coined this kind of a usage for a global platform. So this became kind of recognized everywhere. Uh, it is when a person accepts an ideology and then starts practicing it that people observe it. Till then, it is during the beginning of the 20th century. So till that time, the Roman architecture or the European architecture was considered as wealthy. And this person, he came along and started advocating using the local materials, local resources and all. At that point of time, in the Asian countries, those were the norm. But here, why do we take this example is because it wasn't progressive at that time. It wasn't considered progressive at that time. Yet he managed to make it popular even during his time. This is his own. Uh, this is his office, Taliesin West, which is much regarded, and it is made in a desert using the stones from the site itself. So here, what we generally saw of from being local is this being more labor oriented. Materials is locally sourced in the contemporary times. I'm not sure whether we'll be able to, especially in Kerala, we don't have any local materials. Like everything is sourced out. We are more dependent on building materials from elsewhere. And like we've got projects where the carpentry is being done in Indonesia and being brought here. So is it good, is it bad? I'm not really sure from the economic part. It is working out to be much more beautiful and economical than the local versions. But as a principle, we need to we need to encourage the labor part, the labor or the worker crowd to come and make themselves more economical and user friendly. Why do I say this? In this COVID times, we know that we are running short of migrant laborers. And in project management, you might already been facing this issue. Like we don't have laborers to construct our projects now. We are running short of these human resources. Now, when we depend on the local resources here, it is working out costly. That is where we need to convince the crowd what are the parameters of existence. Only if you exist that I can also exist. So I need to encourage the skilled laborers or the workers that what are the parameters that both of us can exist together. It is a new domain now. It is a new context now. So we need to look into those resources, and I think there are already initiatives being carried out. Just to remind you how this principle or the subject of project management came into being is from the very resource management, the human resource management during the industrial revolution time. The major project management theory that was formulated is during 1911 by Frederick Taylor. Frederick Taylor was the first person to organize this subject called management. I think he is called the father of management. He or Henry Fayol, both were the ones who started this management theory. So in both their works, it was how to manage the workmen. Like during the Industrial Revolution, the workers were being converted from smithsmen to farmers. So, so, so during the conversion period, it was generally considered if you work faster, you would run short of work. So it required a lot of energy. It required a lot of convincing from the management point to convince them See, if you finish your work early, doesn't mean that you are going to run out of work. It means that we'll be able to accept more of production. So that was how the subject of management came into being. How the scientific study of how much time does a man take to accomplish his work and how can it be improved. So this is where the entire production capacity, the studies on production capacity and all started came into being. So I think this is the time where we need to consider all these techniques on making use of our local resources in terms of human resources more efficiently. So it is actually an effort on both sides. It is an efficiency where we need to convince them these are our convertible resources material. So we're coming to the end part. I think time is also done, but I'll just finish off with two more slides. So while we speak about being local and being global, so importing materials, we do not have any kind of materials here. What are the materials that I can use around us? Mud again, brick, concrete blocks. All these have components of import. While I think we need to emphasize more on the labor part, worker part. So that would give a kind of sustenance, economic sustenance to the whole society. And in fact, that was Gandhiji's one of the economic principles that Gandhiji used to advocate about. He was not against machinery. This when a sewing machine was brought, he said, okay, now we've got an efficient way to work. So machinery, use of machinery or use of techniques is good, but it has to give an opportunity for production of more things. Next is the ascetics of being more with less. So what does it mean by being more with less? So here is where we speak about the want and need of a person. Whenever a client comes, there are times when a client has come to build a 10,000 square foot house, and I'm happy to do that because I'll be getting more money in terms of fees. But the conscious part of me has tries to convince him, like, do we really require the square feet? There are people who really require such square feet, and there are people who do it out of a fancy. There are people who do it just to showcase. So we just try and analyze the requirements and try to convince them, is it really required this square feet? Is it really possible to cut off this? You'll be saving a lot of money, and cost saving is one factor where we could convince a lot of things to people and clients. When you say you'll be saving so much of money, that is where most of the clients give it, because we start off from a wrong premise that uh, showcasing or having this materialist aspiration is one parameter of life. So that is where we need to look at Gandhi's another principle and emphasis on plain living. So which helps us cutting down the unnecessary wants and focusing more on the need factor of each and every project and every person. So there we stand as professionals, we stand as a kind of mediator, educating the client whether is it really required, convincing them about the sustainability part. So if a person has got a consumerist aptitude, it is like an animal attitude, like it is my life, it is my need, it is kind of an antagonist point of view. So we need to make this distinguish between what is the standard of, is it do we need a more of standard of living, or should we increase the quality of life, the standard of life? Where standard of living would mean the material, the physical standard of food, cloth, and housing. The standard of life, on the other part, is a realization that the bigness or the rareness of the material possessions that you have is not the standard. And that is where we learn the supreme consideration has to be given to the people around you and to the coming generations. So this is where I would end the discussion on understanding the aesthetics of being more and less. Okay. Thank you.
Thank you.
Over to you, Uni.
Thank you, sir. Thank you for the enlightening session today. And we have a session. We have, I think, 6 questions came in, but the time limit exceeded. So I'll be selecting 2 questions. Can I?
Yeah.
Okay, sir. So there's a question written. It is a practice in Kerala to build truss roofing over the concrete flat roof.
Sorry, what was that?
It is a practice to build truss
Okay.
roofing over the concrete flat roof.
In Kerala, concrete. Okay.
Yeah. Okay.
The question is whether tile roof over truss
Does it?
is recommended in Kerala.
Does it conserve energy? Does it conserve energy or cost?
Surely. Yeah. It does conserve energy in the terms that you're using less of cement and less of steel. In terms of pricing, it is a bit more costlier. And when it comes to using foundation, as I said, it is conserving, on the whole, it is conserving less of energy in the production. And while using truss roof, what we normally face is the leakage problem, as it used to be in the traditional buildings also. Like most of the traditional houses, there is, and it used to be this lifestyle of reusing or reshifting the traditional roofs every 5 years or something. After every major wind, you have the people coming in to relay the tiles. So it used to be there was this leakage problem. So the same thing is there in trussed roof also. But what we normally do is we do an aluminum sheet framework below it, and then on top of that we lay the teak paneling or the PVC paneling or the cement board paneling.
Okay, sir. So the next question, with manpower diminishing and being a big concern, shouldn't construction industry move more towards automation?
Automation, yeah, but how do you automate a building? We've got 3D printing that is in the future, which might be fast coming towards us. I mean, the technology of already Dubai has got a couple of projects that are being 3D printed, so that is completely automation. Absolutely no use of labor. So if you have this one big crane that is going around using materials, and these materials, it is like a slurry that is being poured, and this slurry can utilize all the recycled plastic. That is what the advantage of it. So it is kind of a recycling product. Like just has there are new technologies that are coming with recycled plastic being used in the tarring of road, and it is being thought of as an engineering material also. So this is where technology is going through, but it is not being mass produced. Like what we say about the medicine for COVID. The medicine for COVID has been identified and it has been developed, but now it has to be mass produced to be a vaccine so that it can all be given to the entire population. This COVID can be eradicated. The same way this technology has to be mass produced.
Okay. Thank you, sir. Actually, there are so many questions, but unable to tell the questions because of. So I invite
Okay.
Akhila, the Vice President Finance of PMIK Kerala Chapter, for the vote of thanks. Over to Akhila.
Thank you, Uni, and Architect George Chittoor. It was a great session, sir, and we had opportunity to. I believe I'm audible.
Yeah.
It was indeed a great session, and we got the opportunity to know more about the sustainable building structures. Yeah, I'm sure everyone enjoyed. I was really wondering about these walls on clay jolly and all that. It really just caught my attention. So nice. We are seeing so many sustainable development initiatives there. Thank you. I believe we all will be able to adopt that and then give our posterity a great future. Thank you so much, sir, George sir. And I believe everyone will join me saying a great thanks for starting off our engineering and construction forum with a super webinar from you, and that too in the sustainable line. Thank you so much, sir. And Unnikrishnan, our great engineer who is in our board, he thanks to you, Unnikrishnan, for bringing such a great personality to have a real inauguration. Thank you so much,
Thank you,
Unnikrishnan,
Linda.
too. And
you,
thanks to
Linda.
all the participants who could join in. And we are sorry that we couldn't take all those questions. For sure, Unikrishna will try to get the details shared across. Okay, now let me try to share. I'm just seeing whether I can get the screen shared. 1 minute. I'm not very sure on that. 1 minute. For the PDU session, I'm just trying to share. Let me just check it out. Not very sure on that.
It's okay, Akhila. We will share the PDU code in email.
Is it fine? Or I can just announce it first and then later on we'll send it by mail too. It is C316 GNHCRG. I'll repeat. C316 GNHCRG. And thank you, everyone.
PDU code will be shared separately by email. Thank you all.
Thank you.